1, no forwarding. I2, it is then now fetch, then what? Decode, then execute, then memory, and then what? Write back. But now the problem here, now we want to do I3. I3 will be what? Fetch here, decode here. But now the result is available where? Here. So we need what? One stall. So we need a stall here. We need a stall here. So please remember, we need a stall here. So we need a stall here because we cannot do. And since we have a stall here, we have introduced a stall here. So the other instruction will also be stalled in this cycle. In the execute state, this will be also stalled. So basically, since it's here, since we have introduced a stall here, so it will also be a stall here. We also have a stall here. And then we have execute, then memory, and then we write back. Now, in this case, for I3, now we are reading in I3, it will be, this result will be, okay, this R5, please remember, this R5 will be written in which clock cycle? Help me. Clock cycle 5, and since it will be written to clock cycle 5, it will be provided to the decode stage through LEO 1 or LEO 2? LEO 2. Please remember, now they are not the immediate dependent. They are not the immediate dependent. So it will be provided. So here, this will be, R5 will be provided through LEO. Any question? So then it will be provided through LEO 2. So it will be provided through LEO 2. Then we have execute what? And then memory and what? 1, 2, 3, 4, 5, 6, 7, and 8. How many clock cycles are required? 8. Now, please remember, now we have 3 instructions. So we have one stop. We have 3 instructions and we have one stop. In the previous case, we have 2 instructions and 2 stops. But now we have one stop. Okay, now should I wrap this up? Okay, but if we do it with here, no. So this is not, because there is no forwarding here. Sorry, there is no forwarding here. So a stall will be introduced. Sorry, there is no forwarding here. So this is actually written from the register file to the decode stage. And now we have I2 here. We have fetch, decode, execute, memory, and write back. Then we have the other instruction fetch, decode, execute, memory, and write back. Clear? Okay, now in this case, this is now my I3 now. Here, this value here. Okay, so please remember. Now, let's say I3 is now in the decode stage. I1 will be in which stage? Memory stage. When I1 is in memory stage, so now when it's in memory stage, so the result will be LEO 1 or LEO 2? LEO 2. So it will be forwarded from LEO 2 to the decode stage. Got it or not got it? Any question? Should I proceed?
Why
Yes.
didn't we forward it from LEO 1?
No, because the problem, the result of LEO 1 will contain the result of the I2, not I1. You are not getting my point, one. Because, okay, I got it. Okay, please remember. When I'm in, so now here, I got it. This LEO 1 and LEO 2. LEO 1 will contain the result of what? R3 plus R2. And now here, now this, if this instruction is in execute stage, so LEO 1 will contain the result of what? R6 plus R7. We will get the wrong answer.
Yeah, but my point was, why don't we
So, but this, if it is in LEO 1, which is R3 plus R2, when it moves to the next clock cycle, so that result will be in LEO 2.
okay.
Yes, that's the reason that we have 2 different pipeline registers, so that it should not be overwritten. But again, you got it or not got it? So that's just as if we have B1, B2, and B3, and LEO 1, LEO 2, NPC1, NPC2, NPC3, and so forth.
So this is in the pipeline.
This is in the pipeline. We need to temporarily buffer the intermediate value so that we do not lose the new value. Because this LU is shared between different instructions, different clock cycles. If the new instruction is overwriting the old clock cycle, the old value will be overwritten. And it is not been yet written into register file.
So we need to store it.
You just need to temporarily store it. I hope I answered your question. Any question? Yes?
Like in our instruction 3, we add a new value and execute, so that we can take it from the right back.
No, we are not taking it from the right back. We are directly getting it from the AVOT. Two.
But like we are adding it from AV2 in the decode. We can wait until.
No, we cannot wait. If we can wait until the right back stage, then we have to stall. But now if you look at here, how many? Okay, now here we need a stall. If we need a stall, it means one cycle is added. 1, 2, 3, 4, 5, 6, 7, 8. And if you look at here, 1, 2, 3, 4, 5, 6, 7. So we have saved how many clock cycle? One clock cycle. And we have saved this one clock cycle because of forwarding. You got it or not? Here we were not doing the forwarding. We were writing that value into register file. And we were waiting until that time. Which is efficient or inefficient? Inefficient. Any question now? Clear or not clear? Should we proceed now? Okay, now think of another scenario. So now what I'm going to do, I'm now going to write this out. Please remember, these are all and in the exam I will not give you only 3 instructions, I may give you 7 or 8 instructions. So this may be the question in your midterm too. Should I wrap this up? Good. Again, now the same assumption. Now the same assumption with forwarding and with no forwarding. Now we have another complicated scenario, which is actually LDR. So let's assume we have LDR R5 R3 #10. And then we have the next instruction. So let's assume we have the next instruction. Let's assume add R4 R5. So can you see here? So now this R5 is needed here. Yes or no? Yes? Okay, now what will happen? Now this is my I1 and now this is my I2. If we have this R5, so now we have the I5. So now we have the fetch stage. Okay, please remember, now we are using forwarding. Fetch stage, decode stage, execute stage, main memory stage and magnetic stage. Okay, when R5 will be available to us? When R5 will be available to us? Think of the forwarding scenario. No.
Execute.
No, you are doing the forwarding. When R5 will be available to us? In the memory stage. Because in the memory stage we have, again I will explain it, no problem. I'll explain it. Please remember, we have A, we are calculating the effective address. What do we get? R3 plus 10, then we have LU out 1. This LU out 1 will go to MAR. I'm so many times I'm repeating. And this will go to, so the value of R5 will be available in which clock cycle? Clock cycle 4, which is the memory stage. So now the thing is, so please remember, this value of R3 will go to A, this will go to B, immediate, it will go to op 1, it will go where? Up 2 plus op 1 will go to LU out 1 from MAR, but that result, the value of R5 will be available to us in clock cycle 4 and it will be loaded into LMD. Am I right or not?
Why don't we use LU1 directly?
Which one?
LU1.
Because LU out 1 will contain the effective address. We are not interested in that effective address. I will explain it. Okay. Again. Okay, I will. Okay, let's assume R3 value, please remember, let's assume R3 value is 0x4000 and then we need to add 10 to it. It will be 0x400 what? A. So are we interested in 400A or the content of 400A?
Remember the content.
So why we are asking this question? You're not, now it is in the LU out 1 now. But we do not want this value. So basically we need this value 0x4008 and we need 9. We do not need 4008. I hope I answered your question. Clear or not clear? Clear or not clear? Clear? So please remember this value of 9. Okay, please remember this value 400. So let's assume this 400 and how many times I'm repeating? I'm repeating all this time and it's washed up from your brain. So 400 plus 10 which is 64008, it will go to MAR. It will go to MAR. This value will go to MBR and will go where? LMD. So this value of 6, 9 will be available in LMD in which clock cycle? Clock cycle 4, which is actually the memory access stage. Okay? So now this is available. Okay, now we go. Okay, please remember. Now we need this R5, the updated value R5. In which stage? Decode stage. We need to have this. So now if we fetch it, can we go backward? No. We cannot go backward. So we need a stall here. We need a stall here. And then we decode it. And please remember, from here, it is coming from where? LMD. Please remember, it is with forwarding. It is with forwarding from LMD here. Then we have execute, then we have man memory, and then we have write back. How many clock cycle? 1, 2, 3, 4, 5, 6, 7. 7 clock cycle. Because now we have 1 clock cycle. Any question? Now we are considering the case of no forwarding. No forwarding. Since there is no forwarding, we have to wait until it is written into register file. So if there is no forwarding, so it will go like this. Fetch, decode, execute, man memory, and then what? Right there. And now we have the green instruction. So we have fetch. Please remember, it is now available here. Reading the first half or the second half? First half. If it's not the first half and the second half assumption is not there, we need again another stall. So how many stalls will be there? 2 stalls. And then we decode it because now it's available in the register file. Then we have execute, then we have memory and write back. 1, 2, 3, 4, 5, 6, 7, 8. How many clock cycles? 8. How many stalls? 2. And if we have the now please remember, if we have a structural hazard in the register file, we cannot read and write at the same time, the first cycle and the second hazard. Then we need another stall. So in all these assumptions will be there. Here, please remember, this is no forwarding. No forwarding. With read in the first half and write in what? Second half. And if we exclude this assumption, so no forwarding and structure hazard in register file, how it will look like? Help me. Then we have fetch, then decode, execute, man memory, and write back. But in the next cycle will how? Then we have fetch, decode, execute. No. Since we cannot do it, so we have 1 stall, 2 stall, 3 stall, and it is available in the next cycle. So stall, decode, execute, memory, and write back. So we have now 3 stalls here. And here, in the last example, we have which hazard? The structure hazard. Any question? So it all depends on the assumptions. Any question?
Professor, in the quiz, are you going to give us the table and we just fill it in, or we have to draw the table?
Which one?
In the quiz. Are you going to give us the table with the...
No, there can be different questions. So now, if I ask you to fill in the table, so maybe you will fill the table, but if I give you this question and say, okay, how many stall cycles you will record, so you do not need to know to fill the table.
I mean, in the previous example, we did this one. Like this.
Yes, then you have to fill the table.
Will you give us these and we just fill it?
Yes, we fill it. So it all depends on, and you need to know what will go to LUT1, what will go to LUT2, from where it is forwarded, and blah blah. Any question? Any question? Should we proceed now? Okay. Okay, so now, please remember, here in this case, the successive instruction is now dependent on the preceding instruction. Even with the forwarding, we have 1 stall. And with no forwarding, how many stalls do we have? 2 stalls. Okay, even with no forwarding, but no write in the first half cycle and no read in the second half cycle. 3 stall. Even if it is add instruction and it is add instruction, still we have 3 stall. It all depends on the what? The assumption. So in the exam, the assumption will be given. So different assumption, we will have different result. Any question? Should I proceed? Okay, now what I am going to do, I am going to wrap this up and I am giving you another scenario. We will discuss a lot of these scenarios and I will combine all of these scenarios into one question. So you need to know what's going on. So you need to be very cautious. Should I wrap this up? Okay, now in this example, the following instruction. So please remember the rule. If the following instruction is dependent on the preceding instruction, okay, and the preceding instruction is LDR, even with forwarding, we have one stall. If the following instruction is depending on the preceding instruction, and both of them are add and add, with forwarding, how many stall will you have? 0 stall, no stall. Because it will be forwarded from LU out 1. Clear or not clear? And now, if the following instruction is depending on the preceding instruction, with forwarding, we will have 1 stall. Clear? Any question? Should we proceed? Okay, now think of another scenario. We have I2, add R4, R2, R1, and then we have I3, add R7, R5, R0. Okay, you will do it on your own. Please try to do it on your own.